Hey, what's up, YouTube? This video is going to be a discussion of a way to increase the range of UAVs using methanol electrolysis and hydrogen gas buoyancy. See there, we got a little methanol RC engine, and methanol is used in RC airplanes, and I'm thinking it can be used as a good source of hydrogen for electrolysis and hydrogen gas production for buoyancy for UAVs. So why do RC planes use methanol? Alcohol will keep a platinum filament glowing. There's no need for engine timing to make spark on time. Platinum glows white hot from methanol ignition, which keeps it hot and glowing when electricity is removed. Complexity is reduced. Methanol burns cooler, and methanol burns cleaner. Methanol contains less energy than gasoline, but it burns with more air. That's why it burns cooler, cleaner. Methanol resists icing, which is really big for aviation. Now, the downside of methanol use is it has low volumetric energy compared to, say, like gasoline or diesel. So if not compensated with larger tanks or high efficiency engines, it's not typically used. So this is a exploration of the exotic use of methanol in aviation. Storage ease and infrastructure ease make it attractive because it's extremely prevalent, it's ubiquitous, it's also extremely efficient, carrying hydrogen, packing more hydrogen in one simple methanol molecule than can be found in hydrogen gas because it's a liquid at ambient conditions. While still on the ground, methanol can be handled, stored, and transported with ease by leveraging existing infrastructure that supports the global trade of methanol. And because it will not freeze until it gets as cold as 140 degrees below 0 Fahrenheit, it would be the ideal fuel for high atmosphere operation. So we get into methanol electrolysis for fuel operability. Electrolysis could take the place of propylene oxide, which is used as a fuel additive to make what they call nitro, and also castor oil can be used to increase the combustion flame speed. So when methanol is base fuel, propylene oxide is added to increase combustion flame speed, but a study found that hydrogen enrichment extended the late injection limit of methanol. So this is hydrogen directly added to the combustion chamber. Injection timing improved fuel-air mixing and controlled the combustion process. Injection of the hydrogen. Hydrogen addition to methanol enhanced mixing and combustion. This is a recent study. You can look it up. Methanol electrolysis for electricity and hydrogen production. It's considered more efficient than water primarily because methanol has a lower energy barrier to hydrogen production, meaning it requires less energy to split apart and generate that all-important hydrogen. The voltage and electrical energy needed to produce hydrogen were less than that for water electrolysis. Significantly such, 65% less electrical power was needed compared to water electrolysis. So the theoretical value for the methanol water electrolysis voltage is 0.02 volts, much smaller than the 1.23 volts required for water electrolysis. Nonetheless, water electrolysis is a promising venue for small submersible robots that also want to fly. RoboBee is one such proof of concept developed by MIT. It is submersible. Once the robot swims to the water's surface, lightweight electrolytic plates produce oxyhydrogen from the surrounding water. It's collected by a buoyancy tank. See where I'm going with this? And when the RoboBee is ready to take flight, an igniter creates a spark which combusts the oxyhydrogen and generates enough lift to break the surface tension of water it floats on. And of course, like as we saw in the last slide, methanol electrolysis is more efficient than water electrolysis. Then we get into a new and mysterious drone just breaking the surface. It's the Heaven Drones Raider. Heaven Drones is out of Miami, Florida, USA, and also Israel. The Raider uses hydrogen, which is transferred into a fuel cell, and it has a chemical reaction, and the outcome is electric. That's from their staff member, quote from their staff member. So claiming it has 5 times more energy efficient than a battery. Key points are it's hydrogen fuel cell, over 1,000 kilometer range, around 10 hours flight duration, and up to 50 pounds payload capacity. So the exotic application of hydrogen from methanol would be in hydrogen's lifting power in the high atmosphere. Now we can see that Faraday calculations of methanol electrolysis suggest an extremely efficient method of producing hydrogen and oxygen. Simple 12-volt charging system found in vehicles could be used to power the electrolysis device producing hydrogen and oxygen. The energy you'll get out of using the hydrogen as fuel is not higher than energy you need for electrolysis. And so like middle of atmosphere, as you're ascending, you would switch to just generating hydrogen from the methanol. You would no longer want to be burning it in a combustion engine. Hydrogen is the lightest gas, so it has a higher lifting capacity than other gases like helium. And because it's impossible for a combustion engine to make power in that middle atmosphere and high atmosphere, this is what got me thinking. It would be an exotic airframe, low aspect ratio configuration. It would be akin to a lifting body. Sort of like we see the Vought B173 pictured there, the Vought XFU2. We see NASA's Lark style low aspect ratio configuration. We see the Wayne Fan Facet Mobile fuselage style. Wayne Fan was an engineer for, correct me if I'm wrong, but Northrop Grumman, and then he worked on the NASA Lark project. So it was all about getting cheaper, more efficient personal aircraft. So practicality, the low aspect ratio has a greater useful internal volume since the maximum thickness is greater, which can be used to have payload, and of course the methanol electrolysis engine. So the style of a NASA low aspect ratio, all lifting configuration offers a key benefit at high altitudes, increased structural efficiency, allowing for better load distribution and potentially reduced weight compared to traditional high aspect ratio wings, making it advantageous where air density is significantly lower in the high altitudes and lift generation is more challenging. They would theoretically have a sense of 50-50 fuel harmony for both low and high altitude operation. The proposed UAV would be fueled by methanol internal combustion engine on ground launch, and the UAV would switch to methanol fuel cell electricity production in high atmosphere, where internal combustion engines can't operate. So the UAV range would increase because of the higher density in methanol fuel compared to battery power, and the inability to make power at high altitude would be compensated by the ability to switch to methanol fuel cell power production at high altitude. The hydrogen added to the system would add internal lift to the airframe, but of course computer modeled testing is needed. Theoretical conceptualization of this type of UAV using this sort of airframe is not public at this point, and so that's why I wanted to make this video, to generate discussion, see what your thoughts are. And get this, did you know ammonia is a much better still source of hydrogen for electrolysis than even methanol? And of course, you know ammonia is very prevalent on moons and asteroids in certain places of the solar system. And so theoretically, with extraplanetary flight on these bodies that have high content of ammonia ice, you could produce your own fuel through a hydrogen electrolysis station covered by a giant dome of photovoltaic cells that would power and gather the hydrogen as it rises and would be sucked into a pipeline for processing into fuel cells for rocketry and for vehicles on the surface of that moon. I'm going to make another video about that. Let me know if you like this one. Subscribe, and we'll discuss more ideas. Thanks for watching.